Hello and welcome to this video on electromagnetic waves, properties part 2 and the uses of electromagnetic waves. This is for GCSE Physics and Combined Physics, and don't forget to like and subscribe. Electromagnetic waves are a continuous spectrum of waves that transmit energy from their source to an absorber. They change in frequency as you move from one end to the other, and as the frequency increases, the wavelength decreases. This change in frequency means that the waves interact with materials differently. This means that we can use the different frequency waves for different applications. All electromagnetic waves travel at the same speed in a vacuum. We call this the speed of light, and it is 3 × 10⁸ meters per second. You will need to learn the order of the waves in the electromagnetic spectrum, from radio waves all the way through to gamma. Electromagnetic waves can be absorbed by and emitted from an atom. If an electromagnetic wave of the correct frequency is absorbed by an electron, that electron can be promoted to a higher energy level. This is called excitation. When an electron falls to a lower energy level to fill the gap, it emits electromagnetic waves. An electron moving to a lower energy level is called de-excitation. This is how invisible ink security pens work. Atoms in the dye absorb ultraviolet light and some of the electrons become excited. When they fall back down to lower energy levels, the electromagnetic energy that is released is in the visible light range, and we can see what has been written. Electromagnetic waves are also released from the nucleus of an atom in nuclear decay. When an unstable nucleus undergoes alpha or beta decay, it will need to release some energy. This is released as a high-frequency electromagnetic wave, a gamma ray. The higher frequency electromagnetic waves are also known as ionising radiation. This means that they have enough energy to completely remove an electron from an atom and turn it into a charged particle, an ion. The frequencies with enough energy to ionise an atom are ultraviolet, X-rays and gamma rays. This means these frequencies of radiation are dangerous. Ultraviolet rays can penetrate the top layers of the skin and cause an increased risk of skin cancer. X-rays and gamma rays can penetrate further into the body and cause damage to DNA, which can lead to mutations in DNA. These mutations can kill cells or can cause an increased risk of cancer. As humans are exposed to ionising radiation throughout their lives, we need to be able to monitor their dose of radiation. The dose depends on things like type of ionising radiation and the type of body tissue that absorbed the ionising radiation. We measure the dose in sieverts, capital S, lower v. 1 sievert is quite a large dose of radiation, so for most cases we use the millisievert. 1 sievert is equal to 1000 millisieverts. There's a table here that shows you the comparison of doses from sources of exposure. So 100 grams of Brazil nuts will give you a dose of 0.01 millisieverts. Transatlantic flights will be 0.08 millisieverts. The higher up you go, the greater the exposure to ionising radiation from space. The average annual radon gas dose and the average annual radon gas dose for people living in Cornwall are slightly different. Radon is a radioactive gas produced from the decay of uranium occurring in granite rock. Cornwall is an area of the UK which has a lot of granite, so they have a higher annual dose from radon. Because the way electromagnetic waves interact with substances depends on their wavelength, we can use electromagnetic waves for many different things. So radio waves are used for communication, microwaves, communication and heating food in microwave ovens, infrared radiation, heating food, for example in convection ovens, and heating homes, visible light, cameras and fibre optics, ultraviolet, sunbeds and security inks, X-rays, medical imaging of bones, and gamma radiation is radiotherapy because it kills cancer cells and sterilises medical equipment. A use of radio waves is communication. Production and detection of radio waves is due to the way that radio waves interact with electrical circuits. At the transmitter, an alternating potential difference is used in a circuit to produce an alternating current, AC. This causes the electrons in the circuit to alternate their direction. As the electrons alternate, they produce an electric and magnetic field. This is the radio wave. The radio wave produced will have the same frequency as the alternating potential difference and alternating current. When the radio waves reach the receiver, energy is transferred to the electrons in the circuit of the receiver. This causes the electrons to oscillate, move back and forth. As there is a complete circuit in the receiver, the oscillations cause an alternating current in the circuit. The alternating current has the same frequency as the radio wave signal. Radio waves are used for communication. Some radio wave frequencies can be transmitted over long distances because they can diffract around the Earth, and some can be reflected off the atmosphere, a layer called the ionosphere. This means that signals can be sent even if there is not direct line of sight between the transmitter and the receiver because of the curvature of the Earth. Microwaves. These are used for communication and for heating food in microwave ovens. Microwave frequencies can pass through the atmosphere and so are ideal for satellite communication. Microwave frequencies are absorbed by the water molecules in food. This causes the water molecules to vibrate. The energy in these vibrations is passed through the food and causes a heating effect, which quickly cooks the food. Infrared radiation is used for heating food in a convection oven and for heating homes. All objects will give out infrared radiation, but hot objects give out much more infrared than cold ones. We feel some infrared frequencies as heat. If enough infrared is given out, then we can use it to cook food or heat our homes. Some cameras detect infrared radiation, and this allows us to see objects that have different temperatures at night. This is night vision. Visible light is used for cameras and for fibre optics. This is the frequency range of the electromagnetic spectrum that our eyes detect, so is useful for cameras. Visible light can also be used in fibre optic cables. Information is transmitted along the fibres and can be reflected inside the cable. This means the light can be passed along the inside of the cable over large distances. Light reflects on the inside of the cable and the information is transmitted even if the cable is bent. Ultraviolet. This is used for sunbeds and security ink. UV light penetrates our skin and causes it to protect itself by producing a pigment that tans our skin. Some inks absorb ultraviolet light, and this causes the electrons to move to a higher energy level. As electrons fall back down to lower energy levels, they give out light in the visible range, which we can see. X-rays are used for medical imaging of bones. X-rays are transmitted through the human body, but are absorbed by dense materials like bone. A detector behind the patient will detect X-rays where they have gone through the soft tissues, but will not detect X-rays where the bones are absorbing them. Gamma rays. They're used for radiotherapy because they kill cancer cells and they can sterilise medical equipment. Gamma rays are ionising radiation. They can damage and kill cells. If gamma radiation is directed at a cancerous growth, it will kill these cells. The pathway to the cancer cells must be changed regularly as to not damage the healthy tissues that surround the tumour. Gamma radiation can also be used to kill pathogens on medical equipment. Clean medical equipment in sealed plastic bags is passed near a gamma emitter. The gamma radiation will kill any pathogens present so the equipment can be safely used on the next patient. And that's all for this video. Thank you so much for listening.